All right, so we're on to Unit 24, polygons. Get my pen ready. All right, a polygon is a closed plane figure formed by three or more straight line segments. All right, so by closed plane, like I may have three line segments right here, but this area is all open, so that is not a polygon, as where closed. Okay, that would be a really poor representation of a drawing of a polygon, but it's a triangle. So a convex polygon is a polygon in which no sides, if extended, cuts into each side. So if I take, so if I extend any one of these sides, they never intersect on the inside. So that'd be a convex. Okay. Concave, on the other hand, just imagine those are all straight lines. I extend this line, it doesn't intersect. But as soon as I extend either one of these lines, it cuts into the polygon. So that makes it a concave polygon. And I always think concave as like a hole or like a hole, I guess. And I think about convex as like a hill, just for like reference. So equilateral polygon is a polygon with all sides being equal, and poly means many, gon sides. So many sides. So equilateral is a polygon with all sides equal. Equal angular, the polygons all angles are equal. A regular polygon is a polygon that is both equilateral and equal angular. Okay. All sides and angles are equal. So a square would be considered a regular polygon. Um, Equilateral triangle, regular polygon. Quadrilateral is a polygon with four sides, quad being four. If anybody into four wheeling, you know, you take the quad out. Well, it has four wheels. That's why. Trapezoid is an equilateral or is a quadrilateral that has two sides parallel. So, oh, golly jeepers. My drawing is so poor, especially on the computer. But you get the idea of a trapezoid. A parallelogram is a quadrilateral whose opposite sides are parallel and equal. Um, let's see if I can turn into this. So that would be a parallelogram. A rectangle, you better know what a rectangle looks like. I'll be very disappointed if you don't. A square, yes. A rhombus is a special type of parallelogram whose sides are all equal, but whose angles are not all equal. So it's a square that is tilted to the side, like if you keep the bottom left corner here, I'm just trying this square. Now the same square, obviously not the same square, but it's been kind of shoved to the side. So the sides are the same in imaginary land, and not all the angles are equal. Pentagon, five sides. Hexagon, six sides. Octagon, uh, eight sides. Nonagon, nine sides. And a decagon would be 10 sides. Yeah. So, handy note. The sum of the interior angles of a polygon of n sides is equal to n minus 2 times 180. Okay. So, perfect example is a triangle. 3 minus 2 times 180 degrees is going to equal 180 degrees. If I look at a square, 4 minus 2 times 180 degrees is going to give us 360 degrees. Don't know why and 60 degrees. Okay. So this is an octagon. It's not probably the octagon that you're thinking of from like MMA fighting, but it's still an octagon. It's got 1, 2, 3, 4, 5, 6, 7, 8 sides. All right. So it says find the sum of the interior angles. So we're going to go 8 minus 2 times 180 degrees, which is going to give us 6 times 180, which is 1,080 degrees. I did that in my head, so let's we'll see how mental math worked out. N minus 2. Hey, look at that, 1,080 degrees. So yeah, pretty straightforward. Now the exterior angles for any polygon, if you add them up, they're going to equal 360 degrees. Okay, and that's kind of where I showed you the lines kind of like off. Those are exterior angles. All right, so I'm going to zoom in on this a little bit. So we have 80 degrees, 26 degrees, 58, 84, 62. Now with this information, I can add these exterior angles up. That'll give me the value for angle 6. And then, if you notice, it's a straight line. So I would take that value and take 180 and subtract that value, because the straight line is 180 degrees, and it'll find me the interior angle. So each one of these, if I look at 80 over here, this angle over here is going to be 100. If I look at 26 over here, this is going to be 100 and, wait, hold on. I'm doing math in my head. 154, okay, degrees, and so on and so on and so on. There we go, we're back. So right there, they're adding up the angles, 310 plus angles, 360, so the answer is going to be 50. 50 degrees, and that'll make interior angle A. Anybody? Anybody? No one's raising their hand. So that'll be 130 degrees. Sweet. Now, median of a trapezoid, that is the midpoint of a trapezoid. The median of a trapezoid is parallel to the base and equal to 1/2 the sum of the bases. Okay, so if we add up A and B, AB plus CD, and divide it by 2 or multiply it by 0.5 or 1/2 or however you do it, you're going to find this length. So it says support column B is located midway between 7 points, one column. And again, I like to draw, so I'm going to do, we're going to call that A, we're going to call this one B, we'll call this one C. There's our support column. All right, so this is 10 feet 6 inches. This is 7 feet 6 inches. Excuse me, wrong symbol. 6 inches. And so I'm going to do 10.5 plus 7.5. So, and divide that by 2. So this is going to be 9 feet right there. That'll be 9 feet right there. Drawing a picture always helps. Make sure you draw pictures. So, talking about midway, 9 feet. 1/2 of the sum of the two bases. All right. You'll notice that we have a trapezoid and we got two bases. there, and there. And what this really wants is to determine the distance of A and G right here. And you'll notice that what you're going to have to do is you're going to have to find out what EF is, subtract that from 13 feet 2 inches, okay? That's going to give us, and divide that by 2. So that'll give us HD and AG, okay? Also, the height, doing half, that's going to give us EG. And now we have a right triangle, and with the right triangle, what can we figure out? If we have two sides, the hypotenuse, by using our fancy a squared plus b squared equals c squared. Remember Pythagorean theorem, developed by Pythagoras Doolittle. Must be true. All right, so they're adding up two sides, dividing by 2, gives us 1 foot for AG. All right. And so to determine the length of AB and CD, draw a line from the perimeter to AK as shown. All right, so 2 feet. All right, we have a right triangle right there. Cool. All right, we know the height here. We know the height length there. And we can then just Pythagorean theorem it. So divided by 2 gives 2 feet. 2 feet squared plus 2.75 feet squared. The base and the height gives you 3 feet 5 inches. All right. I know that one kind of quickly. Check the homework. As your questions, specific questions, send them to me, and I will do videos working out those problems that you have questions with. All right. I hope you have had a nice Labor Day weekend, and you'll be getting chapter 25 next on circles. All right.